everyone, today we'll talk about the indicator, which can indicate the acidity of solution. An acid-base indicator is a kind of colorful organic compound producing different colors as the pH changes. The color of indicator is relative to its internal structure. It is used in the acid-base titration. The pH test strips used in labs are prepared by multiple indicators mixed at a certain ratio. Phenolphthalein is a commonly used type in acid-base indicators. Let's have a look at the structural changes of phenolphthalein at different pH. It can be seen from the table that, under different pH conditions, phenolphthalein PP will accept or lose protons and undergo different structural changes. For example, when pH less than 0, PP combines with excess of protons and bears a positive charge. When pH larger than 12, hydrogen ions of the hydroxyl and carboxyl groups linking to the benzene ring are completely lost, with 3 negative charges. PP is orange at pH less than 0 and pink between pH 8.2 to 12. The primary indicator pH range is also greater than 8.2. Next, we will further discuss the principle of color change and the transition range of acid-base indicators. HIN stands for the acid form of an acid-base indicator, which is usually a weak organic acid or weak organic base. The corresponding conjugate acid or base form has different color. According to its dissociation equation, we can learn that when the pH is high, the indicator loses hydrogen ions and obtain a base form with a specific color. When the pH is low, the indicator gets hydrogen ions, present in the acid form with another color. When the reaction reaches equilibrium, its equilibrium constant and calculation equation for corresponding pH are listed as follows. These cases can be discussed based on the calculation equation of pH. First, when concentration of ion divided by HIN equals 1, the color appears to be intermediate and pH equals pKa, which is a transition point. Second, when concentration of ion divided by HIN larger than 10, the indicator represents the color of base form, which pH larger than pKa plus 1. Third, when concentration divided by HIN concentration less than 1/10, the indicator represents the color of acid form, with pH less than pKa minus 1. Notice that individuals in practice can differ significantly in their ability to distinguish between colors. Therefore, the theoretical transition range may deviate from the actual range observed by human eyes. Then let's discuss the factors that affect the color transition range of acid-base indicators. It mainly includes the following points. 1. The amount of indicator. If an excess amount of indicator is added, it becomes dark and is not easy to produce color change. There will be the titration error because the indicator itself consumes the titrant. For example, for a monochrome indicator such as PP, when the amount of the indicator is large, the transition range moves because the lowest concentration C0 of the red color observed by the human eye is fixed. When the indicator concentration C here increases, the corresponding hydrogen ion concentration also increases, leading to the change of pH pointed by the indicator. If too less indicator, it is over-diluted, and the color is too difficult for human eyes to observe. Second, temperature. Temperature influences the dissociation constant of the indicator, thus the color transition range of the indicator. Third, solvent. pKa of HIN varies in different solvents, and pKa is closely related to the color transition range of the indicator. For example, pKa of phenol red in water is 8 and changes to 13.55 in ethanol. Fourth, salt of electrolyte. A. The activity and activity coefficient of salt change and affect Ka. B. Some salts are colorful, producing color complementary of indicator. C. Some salts form colloidal and absorb indicators. Indicators we studied before are monochrome, the disadvantage of which is too wide transition range. If introducing mixed indicator, the complementary colors sharpen the color observation and obviously narrow the transition range. There are two methods to prepare the mixed indicators. 1. Mixed indicator and an inert dye, the color of which remains constant as the pH changes. Second, mix two indicators with different pH transition range. The intersectional color range of two indicators can narrow the final transition range. For instance, a mixed indicator, methyl red and bromo cresol green. The color transition range of methyl red is pH 4.4 to 6.2, while that of bromo cresol green is 3.8 to 5.4. Both ranges are nearly 2 pH units. From this cartoon, we can see that after the mixing of two indicators, the transition range is clearly narrow and the color observation is sharpened. The commonly used acid-base indicators can be checked out in some guidebooks. By analyzing the color change of the indicator at a different pH, the optimal indicator can be selected in the acid-base titration system. Till now, we have finished the relevant content of the acid-base indicator. Thank you for your precipitation. Hope to see you next time.